Welcome back. This is where Nginx stops being just a web server. For the first 4 lessons, we lived entirely inside the HTTP block. Today we step into its parallel universe, the stream module. Same binary, same workers, same upstream syntax, but a completely different rule set operating at layer 4. That means TCP and UDP load balancing for Postgres, Redis, MQTT, DNS, anything that speaks bytes. The trade-off, and we'll keep coming back to this, no layer 7 inspection. Nginx isn't parsing SQL or HTTP here. It's just forwarding bytes. Powerful, and as you'll see, occasionally dangerous. Here's the mental model. Stream sits at the same top level as HTTP in your nginx.conf. Siblings, not nested. Same directive vocabulary too. Server, listen, upstream, proxy pass, proxy timeout. But the layer 7 toys are gone. No location blocks, no rewrites, no header manipulation. Today we'll walk through 4 concrete uses: the stream block itself, TCP load balancing, SNI routing with SSL pre-read, and UDP, where Nginx has to fake the very concept of a session. Picture it like this: one Nginx process, but 2 completely separate universes living inside it. On the left, HTTP handles your usual suspects. TLS on 443 and 80 to 443 redirect, upstreams pointing at your web app, your API, your CDN. On the right, stream is terminating Postgres on 5432 and resolving DNS over UDP on 53, balancing across replicas. Same workers, same kernel sockets, 2 disjoint listen sets, 2 disjoint upstream pools, and crucially, 0 crosstalk between them. So let's make that concrete with the most common stream use case out there: load balancing Postgres RED replicas. Notice the structure: upstream block, server block, listen, proxy par pass. It's the exact mental model you already have from HTTP, just lifted one context up. Least con fits well here because replica load varies wildly per query. Max fails and fail timeout give you passive health checks for free, and that backup server only takes traffic when the primaries are gone. One detail worth burning in: proxy pass takes a host and port, not a URL. There's no scheme at layer 4 because Nginx has no idea this is even Postgres. Now here's where stream gets genuinely powerful. Turn on SSL pre-read, and Nginx peeks at just the SNI field inside the TLS client hello. No private key, no decryption, nothing terminated. That host name becomes SSL pre-read server name, which you feed through a map into a per-connection upstream variable. 3 HTTPS backends behind one IP and port 443, each holding its own certificate, and Nginx is just shuffling encrypted bytes. The same pattern works for IMAPs, SMTPS, MQTTS, anything that starts with a TLS handshake. Now flip from TCP to UDP, and the abstraction gets stranger. UDP is connectionless. There's no handshake, no fin, nothing to tell Nginx a session ended. So Nginx fakes it. A session is just a client IP and port pair the kernel tracks until proxy timeout fires. The critical knob is proxy responses. For DNS, set it to 1, query in, reply out, done. For syslog, set it to 0, fire and forget. Nginx closes the pseudo session the moment the packet leaves. Get that number wrong, and you either drop legitimate replies or leak sessions until the timeout. So here's the complete picture in one file. Top-level HTTP handles HTTPS on 443, terminating TLS for shop.com and proxying to the web upstream. Right below it, a sibling stream block listens on 5432 and load balances Postgres read replicas with least con. Raw TCP, no certificates, no location blocks. Same binary, same worker processes, same reload cycle. 2 contexts, 2 protocols, 1 Nginx, T away from production. That's the consolidation pattern. 1 fewer daemon to monitor, patch, and page someone about at 3 in the morning. Which raises the obvious question: Why Nginx stream and not Che proxy, the tool literally built for this? 3 honest answers. 1. If you're already running Nginx, consolidation is real. 1 daemon, 1 reload, 1 set of logs. 2. Don't kid yourself about layer 4. Stream forwards bytes. It doesn't understand SQL or Redis or MQTT, so query-level logic still belongs in PG Bouncer or TWEM proxy. And 3, the killer. SSL pre-read lets you route TLS by SNI without ever decrypting it. That's the trick Hey Proxy makes you pay enterprise dollars for. So here's your cheat sheet. Print it, pin it, whatever works. Notice the symmetry. Stream block, upstream pool, server with listen and proxy pass, structurally identical to HTTP. But watch the gotchas. Proxy pass takes a host and port, never a URL, because there's no URL to speak of at layer 4. Listen gets a UDP flag when you need it. And for UDP specifically, proxy.responses tells Nginx how many replies to expect. 0 means fire and forget. 7 directives. That's your production TCP and UDP load balancer. Time to get your hands dirty. 3 exercises, all runnable on a single VM with nothing but Netcat. No real Postgres, no real DNS. First, prove TCP load balancing actually alternates between 2 fake backends. Second, build a UDP DNS forwarder and watch real queries flow through. Third, the interesting one, SL pre-read routing by SNI, where Nginx picks a backend based on the host name in the client hello without ever decrypting the TLS session. Read the hints carefully. They're where the real lessons hide. Before you ship any of this, learn from 5 outages that all started with a config that passed Nginx T. First, proxy. Pass in stream takes a host at port or an upstream name. No scheme, no HTTP ta-apras. Second, listen. 53, without the UDP keyword, silently creates a TCP listener while your DNS clients quietly time out. Third, SL pre-read forwards the encrypted stream untouched, so the backend must terminate TLS itself, not speak plain HTTP. Fourth, the default proxy on timeout is 10 minutes, long enough to pin every worker slot under idle Postgres connections. Set it explicitly. And fifth, the classic copy-paste. Stream AS is top level, parallel to HTTP AS, never nested inside it. So here's the takeaway from Lesson 5. Nginx isn't just an HTTP server. It's a proxy, and the stream module is where that truth becomes operational. You now have a top-level stream block that mirrors HTTP, TCP load balancing, SNI-based routing through SSLR pre-read, and real UDP support with the UDP keyword on listen. Same binary, same workers, 2 parallel worlds. Next up, Lesson 6, Lua and OpenResty, because when config can't, code can. See you there.